Hi, everyone. Welcome and thank you for tuning in. My name is Niv. I'm the head of ML engineering for Aporia. And today we're going to talk about how to reduce the time spent troubleshooting ML production issues. And maybe just a small disclaimer before we start. We had a last minute change of speaker. So for those of you hoping to see Alon, who's our CDO, he'll actually be attending live. So you can hop by the Aporia booth tomorrow or on Thursday, and you can chat with him there. Okay, so let's get started. So spending less time troubleshooting ML issues. So what we'll cover. We'll start with a small, short intro to ML observability, just so we have some baseline of what ML observability really is all about. And then we'll talk about why troubleshooting is such a pain. And from there, we'll understand the need to triage faster. So we triage issues faster, and from there to resolve them much faster. And then we'll cover root cause analysis, and I'll leave a couple of questions at the end for a couple of minutes at the end for questions. All right. So what ML observability is all about and how it's related to reducing time spent on production issues. So ML observability is basically a set of tools that help you understand or give you the ability to measure two main things. So first of all, give you the ability to have visibility into your models in production, how well they're doing, how well they're performing. And second, and perhaps more importantly, is give you the ability to monitor. So that means get automatic alerts when things starts going wrong. So just to understand like the base flow of what ML observability means and how to actually monitor models in production. The very first thing that you start from is the very first thing your model starts from. That's the model inputs. So you want to monitor all your features for things like missing values, outliers, distribution drift, etc. And that's because very similarly to the good old saying, garbage in, garbage out. If the data that your model is getting doesn't make any sense, then the outputs or the predictions that it will make will not make any sense. So the very first thing, the very basic, most basic thing that you want to monitor is the features, inputs, etc. And then those inputs go into the model makes prediction, and the very next thing that you'd want to monitor is the model prediction. So basically, you'd want to monitor the distribution of the predictions to make sure that they did not shift or doesn't shift too much from last week, for example. Let's say that, for example, we have a classic binary classification use case. I'm classifying whether this picture is a cat or a dog. And throughout the history of my model, most of the time there are 60% dogs and 40% cats. And then suddenly this week there are 99% cats. This could mean that there was a real change in the world and everything is okay, but that's less likely. What's more likely is that the images that are introduced are not something that our model knows how to handle. And that could lead us in the direction of finding that issue. So monitoring the distribution of the predictions is also very important. Next thing that you'd want to monitor is the performance. You'd want to monitor things like precision, recall, accuracy, mean square error, whatever metrics fits your model as soon as you have ground truth. And when I say as soon as you have ground truth, this can actually be even months later, because in some use cases, by definition, the models or the ground truths are only available within a couple of months. A good example is churn prediction. So in churn prediction, the goal is to predict X number of days ahead, for example, 6 months ahead, whether or not some employee will drop out of the company or some customer will drop out as a customer. So the goal is to predict churn for 6 months from now. Now, the only time, like by definition, the only way to measure the ground truth is after 6 months, because you cannot know if 3 months later, if the employee will churn in the next 3 months. So you have to wait at least 6 months to get the ground truths, and this affects the importance and the how relevant performance monitoring really is. It's very relevant, but in some use cases, due to the delay, you need to rely on other things as well, because you don't want to wait 6 months to know that something's wrong. And of course, for other cases, for example, like recommendation cases, this can happen in minutes. If you are recommending ads, for example, you know within minutes if someone has clicked the ad or not. So this really differentiates from use case to use case. Now, the last piece that's the most important piece, at least to me, and that is often overlooked, is monitoring business metrics. You want to track things like revenue, savings, conversion rate, or basically any other business metric, and you want to correlate that to the predictions that your model is making, because that is the only way that you'll be able to measure the impact that your models have on the business itself. Because the models can work significantly well, or they may not be performing so well, but they still leave a good or bad impact on the business. I think the best example for that would be a recommendation use case again. Let's say I have a clothing shop and I open this app, like an online shop selling clothes, and every time that someone clicks on an item, there's a small pop-up like underneath that says, hey, if you're interested in this item, you may be interested in X, Y, and Z. And in the past, this was based on like a set of fixed rules that would recommend shirts if they were looking for coats, just as an example. And now we've worked really hard to replace that rule-based system with a fancy new machine learning model, and we're tracking its performance using metrics like NDCG, and it seems to be working well. People are actually clicking on the things that we recommend, and people are actually even buying the things that we recommend. So if we only look at model performance, we may think that everything is going well. But in truth, maybe all of the people that are clicking and buying these recommended items is due to the fact that we're recommending socks, which we don't have a lot of profit from. So let's say we have like a $2 socks that are extremely cheap and easy to buy, so people are reluctant, so that they're more likely to click on them. And the model keeps recommending them because people keep clicking on them. And eventually what the model recommends are the cheaper items that don't generate a lot of profit. So at the end of the day, even though your click rate improved and even though your model's performance improved, the impact on your business may not be that good. So you may be, again, recommending the wrong items or the items that don't generate as much profit. And your revenue may actually be smaller. So tracking the business metrics is also very important. And the reason I'm setting all of this background is because the tool that we will use in order to spend less time troubleshooting production issues is an observability tool. So why is why is finding or troubleshooting production issues so difficult? Why is it such a pain? These are actual quotes from customers or prospects that we talked about. And I'll touch each of them because they're very interesting for different reasons. This is a quote that we specifically heard from a couple of data scientists. So the first one is most of the issues are eventually data pipeline issues. The person who's troubleshooting the models, and that's another quote, I guess that very much relates to the second one. In most of the companies, most of the prospects that we've talked to is the model owner. So that's the data scientist who spent a lot of time creating the model. A lot of the times we hear the saying, he's the only one who can understand what's going on there. And so the data scientist, who is a very well-educated person whose time is worth a lot of money, is the one who actually debugs the issue. But the issue is, the issues are most of the time related to data pipelines. So it's not even the data scientist's issue. And so he's literally debugging for other people. And that's insane, because that's his time is worth, like the data scientist's time is worth, it's a more expensive resource. So having him debug other people's issues, that's obviously not healthy for a business. And the second quote that I guess correlates to that a lot is that only the model owners knows how to find the issue. And that's very bad for a business for a lot of reasons. First of all, again, data scientist is an expensive resource, and instead of working on innovation and working on new models or research, they have to go back and start debugging models that they've created 3 or 4 years ago. And another point that from business perspective, having all the knowledge centralized with one person obviously is not healthy for a business. And it also discourages the data scientists. I'm sure, like, I guess many of the people here listening, maybe data scientists too. So it's quite discouraging that you get called to, instead of working on your new research, you get called to debug issues on a model that you created 2 or 3 years ago, that you know, like 100% in your heart, you know that the model is not the issue, but still you are the one getting called to find it, and you know it's going to be in the data pipeline. So it's quite discouraging for the data scientists. And again, having one point of failure, so one person who's able to debug that, that's obviously bad for business. And maybe the last quote, I guess that's maybe most interesting one. The business stakeholders keep coming to us with doubts about predictions. So the way that you are even becoming aware of the issues is because business stakeholders are coming to you with potential issues. So that means that you're only aware of issues when business stakeholders are aware of issues. And business stakeholders are aware of issues only when they're actually affecting the business. So obviously you don't want to be in this situation. That means that you're pretty much reactive. That's bad for a lot of reasons, right? You know, starting from the ability to, for the data science team or whoever is the model owner, the ability to plan their day, plan their week, plan their time or cycle, however you want to work, is very limited when they have to jump from debugging model X to debugging model Y and react every time to different issues. And secondly, knowing about issues only when they affect the business is obviously bad. You want to catch the issues as early as possible, to avoid having like a big effect on the business. Okay. So just to sort of summarize what we've said, model owners are usually the one that do the troubleshooting, which is obviously bad. They're expensive resources. It's just discouraging for them. It takes, that's one point that we didn't raise before. When the model owner debugs the issue, even though probably like they know by heart that this issue is probably related to the data pipeline, they do not activate or start working on the solution, or they do not reach out to the data pipeline personnel, the personnel who's in charge of that, until they see that it is a problem with the data. So the time that it takes to activate the person who actually is responsible for solving the issue may be quite long. So maybe just 2 days of debugging just to understand who it is that needs to apply a fix. And last point is, as we talked, being reactive instead of proactive. So what do we do about it? How do we fix this very unhealthy situation? Like I probably hinted before, we're going to use the monitoring, the ML observability tool to do that. Okay. Just maybe one point before we actually go to a demonstration. Usually when you debug the issues, when you debug issues in machine learning models, the route that we saw, that we start from model inputs to predictions to performance to business metrics, it's actually the other way around, right? We start from the business impact or the performance impact, and then we boil down or track it back to which features have changed, to what data has changed, to which predictions have changed. Do we have a concept brief? Do we have whatever it is, the root cause? But we start from the end of the pipeline that we saw before. So let me maybe skip back. So we usually start debugging from the business or the model metric. And that's important to understand, because that also allows us to understand what we need to do in order to catch those issues in advance. Because if we can start from the beginning of the pipeline, we may be able to, again, stop issues before they reach the end of the pipeline. So right now I'm going to switch to do like a live sort of session workshop. I'm going to use the Aporia tool, obviously, because that's an ML observability tool, but the concept or what I'm going to talk about, it's relevant to any tool that you'd want to use. And even if you build your own, that's okay. I hope you take away from this talk what it is you need to achieve when you build your own things, and what it is that could help you debug issues, or could help you, again, reduce the time it takes to debug issues. All right. So I'll switch to the Aporia app. All right. So this is the Aporia app, and here I have a model that's going to be the insurance sales prediction. It's a model I created just for this example. The purpose of this model is to predict whether or not someone will buy insurance in order to prioritize sales goals, for example. So in here we see this is just like an overview of all the models that I have in my company, for example. And here I see that there's an alert raised for the model performance. And what I did is I set up a very sort of generic monitor that would alert me when my accuracy drops below 90%. So we see here, we look at the alert, we see here that it was pretty much fixed on 92%, then it dropped to a bit under 90. Again, may not be the worst of issues, but for this example, I'll investigate it and we'll try and find out what's the root cause. So I'll click here, I'll click investigate. It'll take a second. All right. So actually, let me run this again while I speak. Okay, so now that I'm in the investigation, this takes me to, okay, so I'll explain what I'm going to do. This was supposed to be ready in advance, but I guess I want to refresh the page. So the first thing that I'm going to do is I'm going to try and understand, measure the impact, right? Try and understand how much, if there were any segments that were impacted more dramatically. So for example, let's say that this issue affected the US more than it did the UK. So first of all, the first thing I'm going to do is measure the impact. Second thing I'm going to do is find the exact date when it started. Specifically for this issue, I can actually see that this started around October 18th. And check if there's some wider implication. Okay, let's go back, see if we have something that's already pre-filled with the data. Yeah, but for some reason. I love the internet here in Israel. Okay. So while this is running in the background, let me just open the tab and I'll go and show how to set up monitoring. The reason this is taking some time, by the way, this is actually running live. So this connects to a database that I set up in advance and actually runs the query. The database is hosted on AWS. It's hosted on RDS. So this creates a job and connects to that. So it's going to take a couple of seconds. So this is the general data for that model. We see that there are around 50K predictions for the model. It's pretty steady over the last week. the distribution of whether or not people will buy insurance is pretty much uniform, right? It's pretty much equal. The performance, we see that there was a drop again around October 18th. It's not major, but it's still maybe something that we'd want to look at. This very much depends on the bottle itself. We also see that reflecting the precision. So we know that this may actually be an issue. Let's see if that finished. Okay, that's going to take a couple of more seconds and we'll be good to go. Meantime, I'll go to monitors. By the way, I guess that I pretty much threw you into the deep water. This is Aporia. This is we talked about monitoring, providing you with visibility and the ability to monitor. So here you see the visualizations that I guess not really like they're pretty standard here. Did not create anything special, and the monitors are the alerts that we saw raised. Okay, perfect. Now I get it. All right. So now that going back to the issue, we saw that the prediction, the performance dropped from 90%, 92% to around 90, a bit less than 90%. Again, not a major drop. But the very first cell that I set up is I wanted, as I mentioned, I wanted to measure the impact and see if there are segments that were impacted more than others. This heat map shows me what is the what are the segments that I have for different categories or different features in my data. Country is one of the features, platform, etc. And for each of those features, it shows me the performance. So I see that there are very small countries that have very little performance. For example, CI, which I don't even know what it is. There's 2 predictions here, and the accuracy is around 50%, but that makes sense because there are only 2 predictions. It's not something that I want to look at. What's interesting here is that the country, Estonia, by the way, if I click on different things, I see that for platform, I see that the mobile is working a bit less than the desktop, and I can see, again, this is pretty much similar, previously insured, previously accident. So these don't make a lot of difference, but what does make a pretty big impact, what does seem interesting, is the fact that in country ES, which is Spain, I see that the accuracy is about 60%, which is bad, and the size, the number of predictions that I have is relatively large, right? That's 8% almost of the predictions that we have. That's a relatively large segment. So I'm going to click on Apply as Filter, and that will show me what is the performance distribution within the country of Spain. So only look at predictions where the country was Spain. And again, I see something very interesting. I see that when the platform is mobile, that's a very large segment. That's 60%. That's 6%, sorry, of the overall data, and nearly, I'd say, 80% of the entire predictions of Spain that has an accuracy of 50%. That really speaks like, okay, there's a specific issue in that segment. And I see that there are other segments that are performing not like ideally, but they're too small for me to care about. So the size of them is too small. And again, right now, my goal is to understand if there are segments that were impacted more, if there is a large group of data that were impacted from the issue. So I'll click apply as a filter. So again, this will now take me to both countries, Spain and mobile. And here I see that pretty much everything, the accuracy is pretty much bad for every segment within those two segments. So for all groups of data within those two groups, the accuracy is poor. So now I can understand that this issue is probably mostly related to this specific segment. So look at places where country is Spain and platform is mobile. Now, I want to check, like, start and understand. We understood again the impact on the performance. So that's if we go back a bit to the pipeline, we started from an issue here for the model performance, and now we want to understand whether it's the predictions that have changed or it's the model inputs. So again, going back, I look at the drift. So I want to compare the distributions of the predictions between this week and last week, like we talked about, or in this case, this week and last month. So we see here that the differences are pretty minor, right? To the graph on this graph is the Hellinger distance. That's a metric for measuring drift between two distributions. And then to your right, you actually see the distribution. And down here is the number of predictions. So again, these Hellinger distance of 0.03 at the maximum, that's not enough. That's not something that I consider significant, and that's not. We can also see it visually from the distribution. So that's probably not a problem. And then we also look at the other features. So the other features I have is age, country, previous accident, income, and platform. So here again, I don't see any feature that's very much drifted. Distances are pretty small. I look at the minimum and maximum. Again, not a lot of difference. What I do see here is that there's some missing values in the previous accident and previously insured, which may be interesting. So again, I started from the performance impact, and then I'm trying to find out what is causing this performance impact. What changed? So this seems interesting, right? We have some around 9% of missing values. Let's see how that fares specifically for the predictions where the country is Spain and the platform is mobile. So click on another tab here that I prepared in advance. So here I filter the data to only look on my data where the country is Spain and the platform is mobile. So now I look at the same widget. This shows me again the data stats. It shows me the missing percentage, the distance, etc. Now this is very interesting. This shows me that I have 100% missing values for these two features. So for previously insured and previous accident. Hellinger distance is extremely high, 0.71. This really points me towards the actual issue. And just so I'm sure that I'm not blaming anyone for no reason, I have the data points cell here, and I'm literally looking at the data itself, and I see that these are all nulls, right? So I see that these are nulls, and this raises a flag. So now we pretty much know that the problem is somewhere in the data pipeline. For some reason, when for Spain and for the platform mobile, then these two features are coming as null. And now I know that this is, again, as we talked about, this is a data pipeline issue. So I'll write it down and leave it or contact the right people who are in charge. So I found the issue relatively fast here, and I was able at least to determine that this is a pipeline, an issue somewhere in the data pipeline. This may be due to fetching this information from third parties that doesn't work anymore. We ran out of tokens. These things happen a lot. Or this may be due to a new version that we released for the mobile app for Spain, and that doesn't work. Whatever the reason is, this is what's causing the performance to degrade. Now, I think that from a business perspective, let's talk about the interesting things from a business perspective here. First of all, and this is very important, this entire thing, it's documented. So this, at least in a Aporia system, this investigation room, it remains documented, and it's also documented with the relevant alert, right? It's related to the alert. If I go here, I see the alerts that are related to that. If I go through the actual monitor, and that's going to take a couple of seconds. So we know which alert this correlates to. So this allows, as a business, this is very important for business to implement, track the issues, track the number of times this was a data pipeline issue, track the number of times this was actually issues with the model, track the number of times this was not really an issue. You really want to track these things because this allows you to, at the end of the day, quantify how well you're doing as a business. And the second thing that it does is that the next time that someone needs to look at an issue like this, even if it's the data scientist that did this initial analysis that I just did, the next time someone else can do it because everything is documented. So use tools that document your process as you go and that are easy for other less technical personnel to replicate. And I think this analysis is relatively easy because, again, all of the cells are created in advance. You can click, you can apply a filter. So everything is created in advance. And this will allow, at the end of the day, the data scientist to offload this mission or offload this initial analysis to someone else. And this allows you as a business to triage the issue and find whoever it is that needs to handle this issue much faster. Now, the second thing, which is a best practice that again, I think everyone should take, is that once you find an issue, so right now we know that the issue is specifically with Spain and platform mobile. Now that we know that these issues can occur, so we could have an issue that's specific to some features in some country. I want to start getting automatic alerts on that. The next time this issue happens, I don't want to have the data scientist look at the data again. I don't want to have someone else look at the data again. I want to get an alert before I even see the impact on the model performance. So remember, the model performance here was aggregated over a week. So I only saw the impact at the end of the week when I could have known about it on day one. So again, whatever tool you choose, I'm using Aporia just to show you, it doesn't really matter, but whatever tool you use, create an automatic monitor, something to alert you when this happens. So after, again, I saw the issue, I saw what's the root cause, I'm going to create a monitor. Specifically, this is due to missing values. And now I'll want to create an alert to notify me that for each country, right, doesn't matter which country, for each country, if the number of missing values for any feature is more than, let's make it 20%, so it doesn't spam us, send an alert. And the second piece here is that I want to alert the correct person, right? Because I've already tried this issue. I know who's the best person to handle that. So instead of notifying this person, I'll send it directly to ES data engineers at Aporia.com. So next time, again, this issue happens, the data scientist doesn't even have to be involved. And we shorten the cycle to fix it. It becomes like exponentially shorter to fix the issue. So again, these are just best practices that you should use, that you should follow when you do root cause analysis, when you do investigate issues, even if it is for the first time, it is a professional or the data scientist that looks at it. For the second and third time, make sure it's not the same person. Let's say monitor here, just now for the next time, I'll get an automatic alert. All right. So let me just stop my share. Okay, so I guess we're pretty much at the end. So do we have, does anyone have any questions? I'll look at the chat now. Maybe I'll summarize before I look at the chat. The key takeaways that you should take away from this talk is, first of all, whatever tools you use, make sure that they're tools that allow you to hand over the information and the responsibilities from the most expensive personnel that you have to someone else on the team that may be able to debug or at least try as issues. Make sure that you use that whenever you find an issue, the next time that this issue occurs, it's found automatically, it's reported automatically. Don't repeat the same investigation twice. Do it only once. And maybe lastly, make sure that you're on top of the issues. So make sure that even if there are too many alerts, you want to, it's better to, okay, maybe I'll not say that, but most of the time it's better to get a little bit alert fatigue than have an actual issue that really disrupts your business. All right, so now if there are any questions, I'll be happy to answer. Regarding this example, we're actually seeing it a lot that people, well, a lot of models that are being deployed, they're actually replacing null values automatically by zeros or something like that. So the model continues to work, but the predictions are obviously not making any sense. Yeah, I know, but this is a very common practice for some reason, because they're it's harder for people to debug issues when the model, harder for people to see exceptions than it is to see wrong predictions for some reason. I know that's bad practice. Yeah, definitely. Those issues should definitely be quarantined. Again, what I'm showing here is what we actually got from, I would never share which customers, but these are things that we got from our customers, from our experience with companies that are actively, that have ML products in production. That's something that they do quite often. Either that, or I did see some better practice is to have a couple of models trained, that if one feature is missing, they go to a model that accepts 3 features. And if another, that's also practice that I've seen employed. Not, again, I'm not a great advocate of that, but that works. For notifications, Slack, Teams, email, we have PagerDuty that you'd only see if you set up the account with PagerDuty. Can't remember what else. I think email, Slack, Teams, PagerDuty. So Aporia is specifically for production ML. So not production ML, for production use cases. So ML flow would be if you look at the flow, you'd start with mflow, run your experiment tracking with mflow. You can actually report the versions directly from mflow to Aporia when you deploy. So you can, like, when you deploy a version, you get the automatic you can create a pipeline that automates deployments to Aporia as well. But the goal of Aporia is to sit where pretty much mflow ends. So that's when your model is live on production and you have actual live predictions. I'm not familiar with Seldon Alibi. Not familiar with those. I guess similar products, Y Labs, Fielder, or Arthur, similar products. Haven't seen really anything that's open source that's good, but I do see people trying to build their own. So using, they automated the metrics calculation and then put it on dashboard like Grafana. It's not ideal, wouldn't recommend it, but that's something that some people do. There are other questions. I'll stay in the chat, but I'll drop off and I'll give you guys 10 minutes of your time back, give or take. Feel free to add me on LinkedIn, message me on email. Unfortunately, due to the last minute change, I don't have a slide with my email, but it's niv@aporia.com. That's pretty easy. And feel free to hop by the Aporia booth. Thank you for listening.